In this little movie, we're going to talk about solving problems by ratios using Newton's second law. Let's start with this example problem. A pickup truck is traveling down the road when a meteor equal to half the mass of the truck drops into the truck's bed, and the truck quadruples its force. So its engine's working 4 times harder now. How does the truck's new acceleration compare to the old? First off, we got to figure out which formula to use to solve this. In this case, we're just starting off real easy and there's only one possible formula we could use. But what we normally do is we look at what we have and what's changed. So we're going to look at the problem for our givens. So now the force is altered, and the acceleration changes. That's what we're trying to figure out, is how the acceleration changes. So these givens tell us we're going to have to use the formula F equals ma. In future units, you're going to have to choose which formula to use, but for right now, it's nice and simple, just one to go with. So we're going to start with F equals ma. The way we're always going to set up ratio problems is you're going to take your new formula with the factor changes on top and then make a fraction with the old formula unchanged on the bottom. Let me show you what I mean. So we're going to start with our old formula, which is just F equals ma, on the bottom of the fraction. It's going to quadruple its force, so we're going to write that as 4F. So the factor change for the force is 4. And we still got the m and the a to deal with. So it's going to travel with half the mass of the truck, or 1.5 the mass of the truck, so that's 1.5 times the mass. And we're going to try to figure out what happens to the acceleration, because that's what we're after, is comparing one acceleration to another. So when we set this up, next thing to do is to divide out our fraction. So our two forces divide out, the masses divide out, and the accelerations divide out. And that leaves us with a new formula. 4 is equal to 1.5 times x. So x is equal to 2.6 repeating. But this isn't the final answer. The final answer is written as a statement, where we're going to write the new acceleration as 2.6 times the old acceleration. Actually, it should probably be 2.7 times the old acceleration. These kind of problems, they say things like compare, or they might say by what factor does something change. And there's also not a lot of numbers given. It's usually things like quadruples and triples and doubles and halves and some fractions in there. So without any real numbers, you're able to find some kind of relationship between, in this case, the old acceleration and the new acceleration. From here, just go on to the next slide and see if you can figure out this example problem.